Alright, so let's start the miscellaneous exercises. Here, the first few are some things we have to prove. So this is the first one. We have to prove that 2 cos pi over 13 cos 9 pi over 13 plus cos 3 pi over 13 plus, this is not product, okay, plus cos 5 pi over 13 equals 0. So let's see how this becomes 0. So what is the strategy here? We are going to apply cos C plus cos D formula to these last two terms. And there also we are going to write this one first followed by this one. You will see why. It's not necessary, but it will give you a little advantage. So we first of all have 2 cos pi over 13 times cos 9 pi over 13 plus cos 5 pi over 13 plus cos 3 pi over 13. So this part we are going to apply our formula to. Cos 9 pi over 13 plus, and the formula for cos C plus cos D is 2 cos C plus D by 2 times cos C minus D divided by 2. That divided by 2 part we write first because we already have ratios here. 5 pi over 13 plus 3 pi over 13 times cos 1 over 2 minus 3 pi over 13. So this equals 2 cos pi over 13 times cos 9 pi over 13 plus. So now what will this be? 5 plus 3 is 8. 8 divided by 2 is 4. 4 pi over 13. Similarly, 5 minus 3 is 2, 2 divided by 2 is 1. That means cos pi over 13. Actually, if we did not slightly rearrange these two terms, it would not have been any big problem. The difference is that here you would get 3 pi minus 5 pi. That will give you here minus pi over 13 instead of pi over 13. But inside cosine, if you have minus, you can replace that by the plus version of the angle because cos minus theta equal to cos theta. But for that you have to write one more line. That's why I just rearranged these two things. So now you can see that you can take 2 cos pi over 13 common out. Times. So what do we have inside? 9 pi over 13 plus cos 4 pi over 13. So So we have to apply cos c plus cos d formula once more. Cos times, let me write here, again another 2 will come because of the formula, 1/2 times c plus d. Times another cos term. So that other cos term will be like this one, but here there will be a minus instead of plus. Minus 4 pi over RT. 2 cos, actually we can write 4 because 2 times 2 times, so what will this be? 9 plus 4 is 13, 13 divided by 13 is 1, so we can write cos pi over 2 times, what will this be? 5 cos 5 pi divided by 2 times 13 is 26, and this is 0 because of this term, cos pi over 2 is 0, and that's how we get 0. Okay, so that is the that's what we wanted to prove. Next, number 2, sin 3x plus sin x times sin x plus cos 3x minus cos x times cos x is equal to 0. Now here of course it's tempting to use the sin c plus sin d formula here and use cos c minus cos d formula here in that second term, but actually you do not have to do those things. I mean, you can, if you want, you can go in, you can take that approach, but instead let us notice something else. It will be easier to do the multiplication here and then rearrange the terms. That way we will get 0 quicker. How? Let me first multiply this and this, that is cos 3x cos x, and write that first. But of course we have to start the problem with this one only. Sin 3x plus sin x times sin x plus cos 3x minus cos x times cos x. So we multiply these two first and write that product, and then with that we write sin 3x sin x. You can probably already see why. We keep these two things together, but there are still more things. Sin square x minus cos square x. and those two terms we keep together. Okay, now you can see that this already is in the for the cosine double, not double angle formula, but cosine difference of angles formula. Cos A cos B plus sin A sin B is cos A minus B minus x, and let's if you take minus sign outside, you can write this second part as cos square x minus sin square x. So this of course becomes cos 2x, and what is this? By the cosine double angle formula, this is also cos 2x, and that's how you get 0 without having to apply the sin C plus sin D formula, dealing with division by 2. Without doing those things, we can still get 0. Okay, next the third one. Here cos x plus cos y whole squared plus sin x minus sin y whole squared, you have to show that this is equal to 4 times cos squared x plus y divided by 2. We have plus sin x minus sin y whole square. So we are going to expand the squares and also rearrange the terms. Rearrange the terms means, you see, if you expand the first square, you are going to get cos square x, and expanding the second square, you are also going to get sin square x. So we take them together and they will give us 1. Another one you are going to get from cos square y and sin square y. So this is how we rearrange the expanded terms. Sin square y plus 2 times cos x cos y minus sin x sin y. But let's see if this really is what we are going to get if we expand these two squares. What shall we get from the first square? Cos square x plus cos square y plus 2 cos x cos y. Cos square x plus cos square y plus 2 cos x cos y. And expanding the second one, we are going to get sin square x plus sin square y minus 2 sin x sin y. Yes, it's correct. But now we get 1 plus 1, 1 plus 1 plus 2. What is this one? This is cosine of x plus y. So 2 plus 2, that means if we take 2 outside, we get this. And now this, instead of simply writing x plus y, we can also write 2 times x plus y divided by 2. And then you apply the cosine double angle formula. 1 plus cos 2 theta is 2 cos square theta. So that 2 and this 2 will give us 4. Cos square, what is theta? Theta is this thing. So that's how you get that. There is a similar one. In this second one we get sine square instead of cos square. Oh, so I can, okay, I can write it here itself. Yeah, why did I even clean this part? 4. So in this case, we have cos x minus cos y whole square plus sin x minus sin y whole square. And in this case, you have to show this. So let's just modify this previous solution. We have cos x minus cos y square plus sin x minus sin y square. So what will be the difference? These two things we are going to get as it is, as they were before in the previous solution. However, we won't get here plus 2 cos x cos y. That is the difference. From this expansion, we are going to get minus 2 cos x cos y. So both of these terms are going to be minus, and that's how we get a plus inside. Do you understand? Minus 2 cos x cos y minus 2 sin x sin y. So minus 2 times cos x cos y plus sin x sin y. However, I think there is, yes, this is minus. It's not just simply sine, this is minus, yes. So now it's clear, because from this we get 1, from this also we get 1, I mean they are 1 both, and this is minus 2, but cos x cos y plus sin x sin y is what? Cosine of x minus y. And here we will get 1 minus this. But 1 minus cos 2 theta is 2 sin square theta. So that way we get 4 sin square x minus y divided by 2. So that's the fourth one. Okay. Next, let us see the fifth one. In this one, we have to prove sin x plus sin 3x plus sin 5x plus sin 7x equals 4 cos x cos 2x sin 4x. When you have a sum like this where there are multiple trigonometric terms, I have told you before, I mean you can of course, I mean that's the only possible way here for us. You can actually write expressions for sin 3x, sin 5x, such things are also available in terms of sin x, cos x, these things. But that's not what we are talking about here. We do not know those things. I mean, we know, but they won't be useful here. Instead, we know very clearly that we have to use sin c plus sin d formula here. But which signs are you going to consider together? You remember that we devised a kind of rule by thinking of which arrangement will give us common terms. If you consider x and 3x, you are obviously going to get x plus 3x divided by 2 and x minus 3x divided by 2. But then you will also consider 5 and 7 together. X plus 3x is 4x. 4x divided by 2 is 2x. 5 plus 7 is 12. Okay, 12 divided by 2 is 6. 6x and 2x are not the same thing. So, if you think like this, you will quickly realize that it's beneficial to consider sin x and sin 7x together. On the other hand, sin 3x and sin 5x together. Why? Because 7 plus 1 is 8 and 5 plus 3 is also 8. So, that will give us a common term. So, in fact, let's start like that. Sin 7x, let's write the larger one first, plus sin x plus sin 5x plus sin 3x. Okay, so now we are going to apply sin c plus sin d formula. When it comes to sin, we have cross terms. Cross terms means both sin and cos should be available. And when it's plus, sin comes first followed by cosine. What that means is that we have this 7x plus x divided by 2, sin first and then cosine. 7x minus x divided by 2. Plus 2 sin 5x plus 3x divided by 2 times cos 5x minus 3x divided by 2. So, this becomes 8 divided by 2, that is 4. Do you see this sin 4x? This is actually going to be our common term which will come outside. And what is this? 7 minus 1 is 6, 6 over 2 is 3. Plus, here also 8 divided by 2 is 4. And this one, 2 divided by 2 is 1. So, after taking 2 sin 4x outside, we are left with cos 3x plus cos x. Now, to this we have to apply the cos c plus cos b formula. That means 2 cos c plus b by 2 cos c minus b divided by 2. Because you have cosine, so either you have cos cos or sin sin. For plus you have cos cos, for minus you have sin sin. 2 sin 4x times 2 cos 3x plus x divided by 2 times cos 3x minus x divided by 2. So, 2 times 2 is 4, and let us write the terms just like this. 3x minus x is 2x, 2x divided by 2 is 1. So, let us write this first, 4 cos x. then followed by this one. 3 plus 1 is 4, 4 divided by 2 is 2, and then finally sin 4x. So we have what we wanted to show. There are some other problems also here, but that we will do in the next trigonometry video. And in the next one we are going to finally complete trigonometry, and then we can go to complex numbers. And tomorrow we are going to start commutative algebra from Michael Attia's book. So that's just it for tonight. See you tomorrow with that. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice day.